A memristor is a device that can remember its resistance even when the power is turned off. It is considered as the fourth fundamental circuit element, after resistor, capacitor, and inductor. Memristors have many potential applications in memory, logic, neuromorphic computing, and cryptography. One of the challenges of making memristors is to find a suitable material that can change its resistance in response to an electric signal. Some of the materials that have been used for memristors are metal oxides, organic polymers, and nanowires. In this section, we will show you how to print a memristor using a 3D printer and conductive ink. Conductive ink is a type of ink that contains electrically conductive particles, such as carbon or metal. Conductive ink can be used to create circuits and devices on various substrates, such as paper, plastic, or fabric. To print a memristor, you will need a 3D printer that can use both conductive and dielectric ink. Dielectric ink is a type of ink that acts as an insulator and prevents electric current from flowing. Dielectric ink can be used to create layers and patterns that separate the conductive parts of the circuit. You will also need a design file that specifies the shape and size of your memristor. You can use any software that can export your design as a STL or OBJ file, such as CAD or Blender. The design file should include 2 electrodes made of conductive ink, and a thin layer of dielectric ink between them. The dielectric layer should have a gap or a slit that allows some current to pass through when a voltage is applied. This gap or slit is where the memristance effect occurs. Once you have your 3D printer and your design file ready, you can start printing your memristor. Follow these steps. Load the conductive and dielectric ink cartridges into your 3D printer according to the manufacturer's instructions. Import your design file into the 3D printer software and adjust the settings as needed. Make sure you select the correct type of ink for each part of your design. Start the printing process and wait for it to finish. Depending on the size and complexity of your design, this may take from a few minutes to a few hours. Carefully remove your printed memristor from the printer bed and let it dry completely. Test your memristor by connecting it to a power source and a multimeter. You should see that the resistance of your memristor changes depending on the direction and magnitude of the voltage applied. Congratulations! You have successfully printed a memristor using a. You can now use your memristor for various projects involving memory, logic, neuromorphic computing, and cryptography.